Open redirects are a type of vulnerability that happen when an application takes user controllable input and uses it to redirect the user's browser to visit a different URL than was intended. These are usually fairly easy to find because developers tend to not use filters for unintended URLs, or if they do, there's usually a way to bypass it. So if we just click this button here, we can see it redirects to this new site page, right? And if we check in Zap Proxy, we can see that it made a post request to this redirect new URL parameter that then has this new site input right here. So what I'm just going to do is I'm going to copy the URL here and test it out in the browser. I'm just going to enter random string here as the input. And we can see it tried to resolve it, but because there's no ASDF page on this web page, it's just giving us a 404, right? So next thing I would try is to see if we can get this to resolve to an external site like Google. It didn't work, but it also didn't 404. So I would assume there's some sort of filter going on here. So to make this seem less, to make this look less like a URL, or to try and bypass whatever filter there may be, I'm going to remove the colon and the HTTP and just leave these two forward slashes. The browsers are going to typically just infer because there's the two forward slashes that the protocol you're using is HTTP. And that didn't work. So next I will try to URL encode things like the periods, because those might be getting filtered out as well. And that didn't work, so after trying just typical URL encoding, next thing I would try to do is to double URL encode. And there we go, we just found a open redirect vulnerability in this web page. So you might be wondering what the impact of this would be, and like the lowest common denominator usage for this would be a phishing attack. Say for example, an attacker sends you a link to download a file, and because the web page that they're making use of has a open redirect vulnerability, it appears to be a credible link, and in fact it technically is, but when you click it, you get pranked, right? Nobody wants to get pranked, so typically though that's not going to be considered something that's high impact to a bug bounty program, for example. But there may in fact be ways that you can use an open redirect in an exploit chain to get something of higher impact. Say for example, if there's OAuth involved in the web page you're testing, and you may possibly be able to snag people's OAuth tokens with an open redirect vulnerability. Or say you found a SSRF vulnerability, but there's a blacklist for certain URLs. You may be able to use an open redirect vulnerability to bypass a blacklist in that type of a scenario. Or, depending on the implementation of the open redirect, you may be able to find something like cross-site scripting. Say for example, let's just turn the brake on here on Zap. Let's click this button here, and we can see that there's this new site URL parameter that's then redirecting us to the web root, right? And because it's resolving, we can actually, and we actually can see as well that it is vulnerable to an open redirect, right? Weird thing is though, if we look at the source code, there's not really any HTML tags that are making the button here. All that we really have are for files that are being called in to the page. For example, the Pepe picture right here, and this JavaScript file. And if we click on that, which is kind of hard to read, but we open up our debugger. There's a file right here. We can try and printify that. We can see that the redirect is being made entirely in the DOM of the browser. And since it's being done entirely in the DOM, that technically means we could test for something like cross-site scripting. Oop. If I could type. And there we go. So just because it's not typically going to be considered something that's of high impact doesn't mean you can't implement an open redirect into something that could lead to something of greater impact. So there you go. That's open redirect.